There we go. Right, can you guys still hear me?
Yes, we can, sir.
Yes, we can.
Right, I will be sending you guys the question. Okay, maybe I won't need to because I'm going to send you this document anyway. The questions on this document are the same questions that were in your test. So I'll be sending you this document, not necessarily the question paper. All right. Right, so let's look at question 1.1. Right, a fighter plane Q flies at 250 kilometers per hour east, while the velocity of fighter plane P is 210 kilometers per hour west, 35 degrees south. Right. Question 1.1.1. Determine the magnitude and direction of the velocity of P relative to the velocity of plane Q. Right. So this is a relative velocity question. Right. Now, as you should know, that under relative velocity, we essentially have a velocity which we'll take as the object and one that we take as the frame of reference. Right. How we represent the two velocities on the Cartesian plane depends on whether the velocity is an object or the frame of reference. Right. So now, question first. Between looking at the question, determine the magnitude and direction of the velocity of P relative to the velocity of plane Q. Between P and Q, which of those two is our object? So that's not a rhetorical question. I'm waiting for an answer here.
P is the object.
So P is the object, right? We want the velocity of P with respect to Q. So Q here is our frame of reference. Now, what does it mean as far as how we are going to represent the two vectors on the Cartesian plane, right? Remember that the vector of the object you draw on the Cartesian plane exactly as it has been given in the statement. So P, right? P being our object, right? From the statement, they said plane P is 210 kilometers per hour west, 35 degrees south, right? So it means seeing that P is our object, we are going to draw P, or we are going to represent P on the Cartesian plane going west, 35 degrees south, right? And then Q being our frame of reference, we are going to draw in a direction opposite the one that we've been given, right? So they said Q is going east. So because it is our frame of reference for this case, it means we are going to draw it going west, which is the opposite of east. Are we clear here?
Yes, sir.
Right. So the vector of the object you represent on the Cartesian plane in a direction that has been given to you, right? Whereas the direction of the frame of reference you draw on the Cartesian plane in a direction opposite the one that you've been given. Are we clear here?
Yes, sir.
Right. Now let us draw our vectors on the Cartesian plane. Right. We have P is going west, 35 degrees south. Right. So P is going west, 35 degrees south. So it is in the third quadrant. Right. So P is somewhere there. Right. P is somewhere, say, right, let's say there. Right. Right, there is P. And then you get Q, which we will draw in a direction opposite the one that we've been given. Q, they said, is going east. So because it's our frame of reference here, we're going to draw it going west. So you draw P going west. Right? Can everyone still see this?
Yes, sir.
Yep, sir.
right? Right. Let us do this. This one is a bit skewed. Okay, let's put it there. And then this one, this is West 35. Maybe 210. Say maybe there. Right, you can have it right there. Right, so we have this is going west. That's Q. Right, Q is 250. So Q is 250 kilometers per hour. And then P going in that direction. So this direction being, I did something wrong here. What happened here? Okay. Okay, that's fine. So P is 210. So this is 210 kilometers per hour, right? And remember that this here, what this whole angle is what is 35 degrees, right? Hello, people.
35.
Right. So that angle is 35 degrees. Just bear that in mind. So this is 35 degrees, right? Now um we are going to use the parallelogram method. Right? We are going to use the parallelogram method. What you are going to do for homework or part of your homework will be to use the what's the other one? The method of components, right? And see if you get the same thing. Right. So you'll have two homeworks today. You'll go over this question paper, right? And in doing so, you are going to use the method of components, right, for questions under kinematics that require us to either use the method of components or the parallelogram method. Are we clear here?
Sir,
Yes.
I tried using the method of components on this question last night when going through the memo, and I had a bit of trouble getting to the
Okay.
same answer.
Okay, it's fine. We will do it then. It's fine. We'll do both methods. Nah.
Okay, got it.
Yes, please.
Why were you keeping quiet in the first place? What if this guy didn't ask us to do it? Right. So we are going to do the parallelogram method, right? In doing the parallelogram method, right, remember that you have to complete a parallelogram, right? So that essentially means once you have the two original vectors, so P and Q, right, you then complete your parallelogram by drawing your vector, by drawing this vector on this side as well as this vector on this side to complete the parallelogram. Right. So essentially, you just copy this to down there, right? And then we complete our parallelogram, making this dotted. That's making that dotted, right? And then where the two vectors meet, so where this vector and this vector that completes the parallelogram, when they meet, which is the dead point, that is where we will have our resultant. Right? Because remember, the velocity of P relative to Q will be the resultant of this parallelogram, right? Or will be the resultant, if you're using the method of components, it will be the resultant of the method of components, right? So either way, the relative velocity, right, is always the resultant. So essentially what I mean is, it means your resultant or velocity of P relative to Q will be in that direction. Right, so it will be in that direction. Right? Are we clear here?
Yes, sir. So
So,
far, so good.
Right. So now you name your parallelogram. Right. Call it A, call this B, call call this C, call this D. Right? How you name your parallelogram doesn't really matter, right? As long as you name your parallelogram, right, for reference, right? So if that's the case, we are looking for the velocity of P relative to Q, and as we've established that this is the vector that represents the velocity of P relative to Q, right? The resultant velocity of this parallelogram, right? Now remember I said bear in mind that this angle here, right, is what is 35 degrees, right?
Yes, sir.
Right, so that's 35 degrees. Then what is this angle going to be? Remember core interior angles, right?
145.
Right, so core interior angles means the sum of the U forming here, right? So this angle is co-interior with that one, right? So meaning that the sum of them, right, gives us 180 degrees. So to get this angle in particular, seeing that we have this one, you can simply say 180 minus the 35, which is 145. Hence this angle here is 145 degrees. All right, so that's that angle. Are we clear?
Yes, sir.
Am I talking to one person? Is this clear to everyone?
To two people, sir.
Yes,
Yes,
sir.
sir.
Oh, two people. Oh, okay. So I guess there's
Yes,
more.
yes, yes, sir.
All right. Right. Now once your parallelogram is complete, you've labeled it. Now you're good to go. Right. Now in calculating our resultant, you simply you look at the angle that you have. Right. So the angle we have is such that it is between two vectors that we know the magnitude of, making this angle what? The included angle. Right, so this angle is the included angle because it is between two vectors which we know the magnitude of, right? So because the angle we have is an included angle, it means we can make use of the cosine rule, right? We make use of the cosine rule. In making use of the cosine rule in calculating the resultant, which essentially is our velocity of P relative to Q, right? We then name the inside of the triangles, right? So we're going to use, seeing that it is this angle we have, we're going to use triangle ABC, right? So this is the triangle we're going to use, triangle ABC, right? So then we name the inside of our triangles, right? So you have A, or we have angle A, opposite will be the side A, right? And then this side you have angle C, opposite that you will have the side C. So this is side C, and then here you have the angle B, opposite that will be the side B. So this here is side B, right? So essentially, the cos rule, right, will be looking for side B, which represents the resultant of this parallelogram, which in turn represents the velocity of P relative to Q. All right, so using the cosine rule, we simply say in triangle ABC, right? So this is us giving reference to as to which triangle we are using, right? So we are using triangle ABC, right? We are looking for B. So as far as the cosine rule, this will be B squared is equal to, so this will be A squared plus C squared minus A times C, not this, it's 2 times A times C cos B, right? That is the cosine rule. So we say B squared, now you simply just substitute. Now A, right? Remember in a parallelogram, opposite sides are equal, opposite angles are equal as well. Right? So this side being opposite this one means this is 210. So you have 210 there, squared plus C squared, right? C is this side. That is the 250 kilometer side, kilometer per hour. So this is 250 squared minus 2 into A, which is a 210, into C, which is 250 cos B, right? The angle B is 145, right? So B squared is equal to, now what do we get if you punch this in your calculators? I already gave you the memo, right?
You get 1926
1926
10
10
point 96
96
965.
965, right? And then of course we are looking for B, so you apply the square root both sides. Now the square root of this, what does it give us?
It's 438.875.
438,875. So this is kilometers per hour, right? Now, B representing the resultant means that it also represents the velocity of P relative to Q, right? But remember that um, the relative velocity is a vector. So we need both magnitude and direction, right? So we first get direction, and then once we have our direction, we'll write down the final answer. Right? So remember, I always tell you to stick to referencing your angles from the x-axis, right? So referencing the direction of the resultant, so the direction of B, right? Referencing it from the x-axis, it means we'll be looking for this angle, right? So angle A, essentially, that is what we're looking for, all right? So in calculating angle A, we then use the sine rule, right? We're looking for angle A, so we're going to say sine A divided by side A is equal to sine B divided by side B, right? That's the sine rule for this case. So this is sine A divided by side A is equal to sine angle B divided by side B. Right, now what are we looking for? We're looking for A, right? We're looking for angle A. So we multiply both sides by A, hence this side will be left with sine A is equal to, so this will be A sine B divided by side B. Right, we are looking for the angle A. So we then say to get A, we need to calculate the arcsine of this here. Right. So now we substitute. Right, substituting arcsine of side A is equal to 210. So this is 210 kilometers per hour. Sine B, the angle B is 145, right? Divided by side B. Side B we just calculated. It's 438,875. And what do we get here?
15,299.
15,299.
Yep.
299 degrees. All right. Are we getting the same thing here?
929, sir. 15,929.
Oh, 929. So 15,929 degrees. Right. So now that we have this angle, which we intended to get anyway, right? This is the angle we intended to get. So we just calculated it. Now you can write down what the velocity of P relative to Q is, right? So the velocity, you can then say the velocity of P relative to Q is equal to the magnitude, which is 438,875 kilometers per hour. And then you write down the direction, right? Now, if you look at how we referenced our angle, our angle is referenced from the x-axis. The x-axis are such that they are going west. So our angle will be west, right? Because the angle is referenced from the x-axis. The x-axis direction is going west. So we have west first, then our angle being 15,929 degrees. Right, and where is this headed? This is headed south. So you have south there. So this is how we are going to write down our angle. Right. And then the question will now be complete. Right. So in calculating the relative velocity, you must always state both the magnitude and direction. Right. So this is the last step that we want to see there. Are we clear?
So,
Yes, sir.
are we still going to be doing the same question but with method of components?
Yes.
Okay, awesome.
Right. Now, are there any questions here? Right. The most important
So,
thing. Yes.
I have a question by the diagram. Um, when they gave us plane Q, saying that it's 250 kilometers east, can you explain again why did we draw it as it's going west? Are we trying to get all the vectors into the same quadrant?
No, that is not what we're trying to do. Right. What we're trying to do is follow essentially the guidelines as to how we represent vectors on the Cartesian plane regarding if a vector is an object or a frame of reference. Right. If a vector is an object, right, by principle, you draw it on the Cartesian plane going in the same direction as the one that's been given. That's the object, right? The frame of reference, however, you must draw it on the Cartesian plane in a direction that is opposite the one that's been given, right? So it has absolutely nothing to do with getting the vectors to be on the same quadrant or different quadrants, right? It's based off the object or the vector of the object drawing it in a direction that's the same as the one that's been given. And then as far as the frame of reference, right? The frame of reference you draw in a what is this? In a direction that is opposite the one that's been given. That's it.
And in this case, the object is plane Q.
Nope. So since they said determine the magnitude and direction of the velocity of P, right? So we are looking for, so essentially, this is Vp relative to, they said determine the magnitude and direction of the velocity of plane P relative to the velocity of plane Q. This is what you're looking for. Right, so remember what I told you, that the first letter always represents the object, second letter always represents frame of reference. So object is P here, frame of reference is Q, meaning as far as direction on the Cartesian plane, right? P you will draw in a direction that is the same as the one that's been given, and Q being the frame of reference, you'll draw in a direction that is opposite the one that's been given. Are we clear?
All good, yes, sir.
Yes, sir.
Thank you.
Yes, sir. Sir, another question then.
Yes.
Is there a option where we can maybe can we get a question like this where we cannot find the included angle and having to use the sine rule other than the cos rule, or we will always maybe find the included angle so that we use the cos rule, the cosine rule.
Okay, let me say I do not know. No? But I've never come across a question where I use the sine rule in calculating the resultant.
Okay, that's clear, sir.
I think that's the best way to put it. Right. If I think about it, yeah, there's never been a case where I use the sine rule. It has always been the angle I've always been able to calculate was one that essentially became the included angle, hence the use of the cosine rule.
Okay. Thank you, sir.
Yes. Any more questions?
Sir, just to confirm, you're saying that the it's always the object that will take it as it is.
As far as direction, yes.
All right. Maybe I was a bit lost. Okay, no, it's fine.
Right. So the most important thing here is understanding those guidelines. Right. The guidelines being identifying which of the two vectors is your object and which is your frame of reference. Right. The object, right, you then draw on the Cartesian plane in the same direction as the one that's been given to you in the statement. Right. Whereas the frame of reference, right, drawing it on the Cartesian plane, you draw it in a direction that is opposite the one that's been given. Are we clear?
Yes. Sir,
That is the most important thing here. Yes.
sir, I have a question. So you're on the parallelogram method. We don't put that 250 kilometers an hour as a negative.
Nah, no need to, because you've already accounted for that. You drawing the 250 in a direction opposite is you accounting for that.
Okay, so then we don't use any negatives.
Also, okay, so let me put it like this. For the cosine rule, right? For the cosine rule, you don't necessarily do that. Right? Only for the method of components.
Okay.
We will have to consider direction like that.
Okay, it makes sense. Thank you.
Yeah. Right. Any more questions? Right. So now let us look at how we would attempt the same question, but now using the method of components. So this is the parallelogram. Parallelogram of vector diagram method. Parallelogram method. All right, so now we are going to look at how we would attempt the same question, but using the, what is this? The method of components. Method of components. Right. Right. So essentially we draw the Cartesian plane. We use the very same principle, right, in drawing or in representing the what is this, the vectors on the Cartesian plane, right? So objects you draw on the Cartesian plane in the same direction as the one that's been given, right? Whereas the frame of reference you draw in a direction that is opposite the one that's been given, right? So we don't need this anymore. Right. Right. Now using the method of components, right? The vectors we need to annotate in a way that shows in which in which axis the vector is on, right? So meaning if you look at vector q, right? Q was originally going west in the statement, but we've drawn it going. It was originally going east in the statement, but we've drawn it going west on the Cartesian plane. Why? Because Q is our frame of reference here, right? Now, seeing that Q is on the x-axis, right? How we are going to write down the vector Q is by saying that is by essentially taking this vector of q as the component of q in the x direction, right? So essentially this will be vqx. That's what I mean, right? So instead of just calling it vq, seeing that it's on the x-axis, we are going to call it the component of q in the x direction, right? And because there's no component of q in the y direction, it means the component of q in the y direction will essentially be equal to 0. Are we clear here? Hello?
Loud and clear.
Yes, sir.
Right. And then when we look at the vector p, which is our object for this case, right? It is an oblique vector making an angle of 35 degrees with the x-axis, right? So because we have an oblique vector, we need to resolve it into its components, right? So that we are able to apply conditions of equilibrium, right? So resolving vector q into its components, right? We'll have a horizontal component going in that direction, right? And then we'll have y component going in that direction, right? So because this is q, so q is equal to 210, right? So meaning not q, p. This is p, right? So meaning vp in the x direction, right? Because it is headed, I also forgot to do this here, right? I forgot the sign here. All right, so because this is headed west, this we take as negative, and then we're going to do the same thing with the component of p in the x direction, right? Since it is headed west, it is going to be negative. So this will be negative 210, right? Our angle is referenced from the x-axis, meaning the x component will be in terms of cos. So this will be cos 35. All right, so that's the component of p in the x direction. And then we have the component of p in the y direction. It is headed south, therefore it is negative 210. All right, our angle is referenced from the x-axis, hence the y component is in terms of sine 35. Are we clear?
Yes, sir.
Yes,
Right.
sir.
So once you have that, all right, so once you have that, you now can apply conditions of equilibrium because you have vectors that are parallel to the Cartesian plane, right? And applying your conditions of equilibrium, right, we look at the sum of vectors in the x direction, right? So this is, so let's do this. We are looking for p relative to q. So sum of p relative to q in the x direction is going to be equal to, right? So this will be vpx plus vqx, right? And now all we do is add our vectors, right? vpx is negative 210 cos 35 plus vqx, which is negative 250, just negative 250, yes. Right. Now tell me what you get here. What is negative 210 cos 35 minus 250?
Negative
Negative
422.
So minus 422, comma 022, right? Now,
Yes, sir.
the negative sign, right, tells us the direction. So seeing that this is a x component of the resultant, it means that seeing that it is negative, it means it is going west. So that means this is actually 422,022 kilometers per hour, and the negative sign just shows that this is going west. Are we clear?
Yes, sir.
Yes, sir.
So you do not leave this as negative. Right? There is no necessarily such thing as a negative vector. The negative sign shows us direction. Right? And you should show that you understand that part. That this means essentially that that is the magnitude of the component of the resultant in the x direction, and it is going in the in the west direction. Are we clear?
Yes, sir.
Right.
Yes, sir.
So now we again apply conditions of equilibrium, but now in the y. In the y, what is y Cartesian plane? So sum of p relative to q in the y direction. This will be equal to vpy plus vqy, right? Vpy is negative 210 sine 35, right? Plus vqy, there is no component of q in the y direction, right? So that will be 0. So what is negative 210 sine 35?
120,451.
So negative 120, 451. Right. Also, this means that this is actually 120,451 kilometers per hour. Right. It's in the y direction. It is negative, meaning it is going south. Yes. Right. Never leave out the negative sign. Right. If you're going to leave out the negative sign, make sure you indicate the direction. Are we clear?
Yes, sir.
Yes, sir.
Yes, sir.
Right. So we have the components of our resultant. So now we simply can use what is this? Pythagoras to calculate the resultant. Our resultant is the velocity of p relative to q, which will be equal to the square root of right, the square root of the sum of v in the x direction plus the sum of v in the y direction. All of this, right, each of these terms is squared. Right, each of these terms is squared. Right, so this will be equal to, so now we will simply substitute. Right, so substituting, sum of v in the x direction is 422,022 squared plus 120,451 squared. Notice how I didn't use the negative sign here. Right? Why? Because we've already accounted for the negative sign by using that direction. Are we clear?
Yes, sir.
Sir, I have a quick question about this formula that you're using now.
Mhm.
Let's say if you were to say the square root of negative 422, like wouldn't it still cancel out in like
Second,
if you were to account for the negative sign of 422,022, if you were to say negative 422,022, wouldn't it still cancel out in your final answer?
you mean here?
Since yep,
Well, it would,
since
because you're
since
squaring.
you are squaring it.
Well, yes, it'll work out perfectly for you, right? But the fact that you wrote a negative sign here is wrong, because remember, you're still going to calculate the direction. Right? And in
Okay.
calculating your direction, if you do that same mistake, right, it is not going to work in your favor.
Oh, okay, got it.
Right. So as far as the negative sign, you just indicate the direction here, right? So indicating the direction is you getting rid of the negative sign, essentially. Are we clear?
Yes, sir.
Right. So what are we getting here?
That 438,875.
So 438,475.
875.
875. 875 kilometers per hour. Right. Now you have the magnitude of v of the velocity of v, the velocity of p relative to q. Now you need to get the direction. Right. In getting the direction, right, remember I always tell you to reference your angles from the x-axis. In referencing your angles from the x-axis, using the method of components, you simply say tan theta is equal to the sum of y over x. Sum of y is this y divided by the sum of this x, right? So writing down your equation like this is saying you are essentially referencing this from the x-axis. Are we clear?
Yes, sir.
Right. So whatever angle we get here will be referenced from the x-axis. So to get our angle, we need to calculate the arctan of sum of y. Y is 120,451 divided by sum of x, which is 422,022. And what do we get here?
15,929.
So 15,929 degrees, right? So now you can say, therefore, VP relative to Q is equal to the 438, what is it? 438,875 kilometers per hour, right? Our angle is reference from X, right? X here is, if you look here, X is west. So essentially this is west. Angle is 15,929 degrees south. And you get your full marks. Any questions here?
No, sir.
Right.
Sorry, sir.
Mhm.
Hello.
Yes. We're listening, my guy.
Yes, sir. I wanna find out, say, if when you calculating your when you're calculating your vectors there, from calculating your x components and your y components, and then for the fact that you're calculating the
You're cutting off, Chief. Or is it me?
Nah, I can't hear him either.
Oh,
I think it's gone.
he's gone, no?
x
Okay.
component,
He left to catch up.
and that
No, he's back again. He's back again.
means
No,
your
His signal is bad.
yeah, it's either signal. Probably it's the signal. Probably.
The signal.
was
Okay. So sorry, sir.
Meneer.
Yeah, go on.
Okay. I see. Even if you take the object incorrectly, so you choose the wrong incorrect, let's say incorrect object in that statement. I believe that you'll get the same value but the wrong direction, right?
Well, yes, because essentially what you'll be doing is saying you are calculating, for instance, if you mix up the two vectors here and say
Yes.
Q is your object and P is your frame of reference. Essentially, you are saying you are calculating VQ relative to P.
To
The
P,
magnitude
yes.
of the resultant will be the same. The direction will be different, though.
Different. So would you still get marks for getting the values right, but except the direction wrong, or interpreting the statement wrong? You get everything wrong just because you interpreted the statement wrong.
I would give you marks for the resultant, but say like this one, I think this question was 5 marks, right?
Mm.
This question is 5 marks. So depending on mark allocation, like for instance, if this year is just 2 marks, then I'll probably just give you 2 marks, but you would lose the 3 marks for, well, this. And in
Okay.
fact, that would be me looking out for you.
All right.
But I would give you some marks there. Right?
Understood.
So just to clarify,
Mhm.
according the parallelogram or method of components, does it depend on you which one you feel comfortable with?
Depends on you if they haven't specified which method you must use. Right?
Okay.
On your assessments, I won't specify any method. Right? You can use any method you are comfortable with. Right? So
Okay,
as long
thanks,
as
man.
it is not specified, you can use any method.
Okay, meneer.
Right? Any more questions? Right.
Sorry, sir.
Yeah.
I think I missed the part where how do you know which one is an object and which one is not?
Okay.
Like,
So let's read the question here. Right? Determine the magnitude and direction of the velocity of P. Right? Now, that part alone, what does it tell you? You are looking for V of P. Right? Determine the magnitude and direction of the velocity of P. That part alone is telling you you are looking for V, the velocity of P. Now, when you continue with the question, relative to the velocity of plane Q. Now, what does that tell you mathematically? It means you have Q there, right? Now, what do you know about the object and frame of reference, right? The first letter here is your object. Second letter is frame of reference. Even if you write it like this here, P, V, Q. Still, between the two letters, this is the first, making this the object, and the second letter, the frame of reference.
that's clear, sir. Thanks.
Right. Any more questions? No more questions. Right.
No, sir.
Okay. Let us move on to, this was 1.1. So let's move on to 1.2.
Lastly, sir, so if on the exam they ask you to do which method and then you do the different one, so you get 0 because we maybe some of us we comfortable with another one except another one.
I understand the question. It would depend on how the other markers feel about it. So if in the memo discussion it is discussed that we should give you marks regardless of the method you used, then that will be the case, right? Or we could decide, no, you should have stuck to the instruction. Hence, we would have to either take marks or you'd get 0 for the question or that sub question.
All right.
Yeah. Right. Any more questions? Right. But I hardly ever see questions where they specify the kind of method that they want you to use. Right. In fact, I've probably just seen 2, like ever. Right. Questions that are like that, that specify use the vector diagram to determine such and such. Right. I've only seen 2 of those questions, maybe 1. Right. But I hardly ever see those questions. But again, like I said, it'll be convenient if you are comfortable with both methods. We good?
Yes, kind of.
Okay. Right. So then let's look at 1.2. Right. It reads as follows: an aircraft can fly at a velocity of 280 kilometers per hour with no wind interference. Right. As soon as they say with no wind interference, that suggests that this here is the original vector of the aircraft. Right. It must fly to an airport 275 kilometers north of its position. Right. So essentially, they've given us the direction of the resultant. Right. When they say it must fly to an airport that is 275 kilometers north of its position, they're essentially giving us or telling us the direction of the resultant, right? A northwesterly wind with a velocity of 72 kilometers per hour is blowing, right? Now, if you look at the direction of the wind vector, right, it is unclear as to if the wind is coming from this direction or going to this direction. So because the wind direction is ambiguous, remember I said you always, if a wind direction is ambiguous, you take it as though the wind direction is coming from this direction, right? And when you draw the wind vector on the Cartesian plane, right, for such a case, you would then draw it in a direction that is opposite the one that you've been given, right? So again, if you look at the wind vector, a northwesterly wind with a velocity of 72 kilometers per hour is blowing. So they didn't quite specify if the wind vector is coming from this direction, right, or going in this direction. Because of that, we take it as though it is coming from this direction. So if it is coming from this direction, it means it is going in a direction that is opposite the one it is coming from. Are we clear?
Yes, sir.
Or what about the others?
That's an easy one.
Yes, sir.
Okay, beautiful. Now let's look at questions. In fact, before we get to questions, let's represent these vectors on the Cartesian plane. All right. Right. So we have VO, the original vector. Right. The original vector. Okay, so that one we won't draw at the moment because we don't know the direction of the original vector. Right. But the direction of the vectors we do know is the direction of the resultant. Right. We know the direction of the resultant. Right. We know the direction of the resultant. They said this must fly. It must fly to an airport 275 kilometers north of its position. Right. So we know that the aeroplane must end up directly north after flying 275 kilometers. Right. So essentially, we have the direction of the resultant. Right. And we also have the direction of the wind vector. Right. So remember, we established that since the wind vector is unclear as far as if it is coming from or going in this direction, we take it as though it is coming from this direction. Right. So coming from northwest is essentially means that it is going opposite this direction. So south 45 degrees east. Right. Right. So this wind vector is somewhere here. Right. 45. Yeah, somewhere there. Right, so this is going in that direction. Right. So this is VW. So VW, which is the wind vector, VW is 72 kilometers per hour. So this is 72 kilometers per hour. Right. Right. Now, knowing these two vectors gives us an idea as to which direction the original vector, VO, will be going. Right. Because remember, this has to end up directly north. Right. And taking the wind vector into account, right? If this plane was to take off at this point and try to go directly north, right, this wind vector would push it in that direction. So essentially, it would end up somewhere in that direction. Are we agreed here?
Sir, can you please repeat that?
Right. So we've been told that the plane needs to end up, right, in a direction that is directly north after 275 kilometers, right? They said
Okay.
it must fly to an airport 275 kilometers north of its position, right? So we know that this plane must end up directly north of its position. So if this is where it took off, it must end up directly north after traveling 275 kilometers, right? So if you were the pilot here and you tried to fly directly north under these conditions, right, what would tend to happen is that this wind vector would blow you off course, right? So this would blow you off course, right? So because this wind vector is going in that direction, so this wind vector would push this plane, right? It would push the plane in that direction. Right? It would push the plane in that direction, hence the plane would end up somewhere there, which is not directly north. Am I making sense here?
Yes, sir.
Yes, sir.
I got it, sir. Thanks.
Right? So because of that, we have to account for the wind vector and ask ourselves how we would have to fly this aeroplane in order that after flying 275 kilometers, accounting for the wind vector as well, we end up directly north, right? So to end up directly north under these conditions, it means we would need to fly slightly in that direction, right? You would need to fly slightly, say, in that direction, right?
Yes,
So
sir.
you would need to take off at this point, right? Because you need to account for the wind vector blowing in a direction that is southeast, right? You would then have to fly in this direction. The wind vector would then push us essentially back on course, right? So the wind vector would push us back to directly north, such that after flying 235 kilometers, right, we end up directly north. Are we clear?
100.
Yep.
Yep, sir.
Right. So this here will be the original vector of the aeroplane. So this will be VO. So VO, as this here is VO. They gave us the magnitude of VO. It is 280 kilometers per hour. So this is 280 kilometers per hour. Right. Right. So now we complete our parallelogram. Completing the parallelogram. Okay. Right. So this one, for this to be accurate, I'd first have to, right, first draw this one because we know the magnitude as well as the direction of this one. Right. Draw this one there. And then draw this one. Right. Right. And then we have our complete parallelogram. This we know is going in that direction. Right.
Sorry, sir.
Yes.
I think what confused me as well is, doesn't it say there that it can fly 280 kilometers an hour?
It said it must. Oh, you mean here?
Yeah, it can fly 280 with no interference, but there's wind.
Yes. That is why. So when I explained that we cannot take this direction, so we can only fly from this point directly north, if there is no wind interference. Right? So if there was no wind vector, if there was no wind interference, this here would be 280 kilometers per hour. So we'd fly from this point, right, with 280 kilometers per hour and end up directly north. But now there is a wind vector, right? So as far as the speed of the plane or the original speed of the plane, it doesn't change, right? So the only thing that can change is the course.
Okay. I
You see what I'm
thought
saying?
the wind affects the speed of the plane as well.
Second?
No, I thought the wind affects the
Right.
speed of the plane.
Right. I totally get you there.
Oh,
Right.
okay.
So the speed of the speed of the plane isn't going to change. So because of that, it's the course that must change.
Okay.
So we fly in that direction so that the wind vector will then push us back on course.
Okay, makes sense.
Yeah. Right.
Just one more question. Just a question, sir.
Yes.
Do you say would I be wrong if I say wind vector as in the quadrant that is given the northwesterly?
Would you be wrong if? Just say again.
You asked if you would be wrong if you drew that the vector in the northwest quadrant.
Well, yes, because remember we do not draw vectors, right, in a direction that is pointing towards the point of intersection. But our vectors must always be such that they are pointing away. So yes, you'd be wrong.
All right.
Do you get what I'm saying? This is
Yeah, I do.
Yes, yes. Right. So this here is VO. So VO, which is 280 kilometers per hour. Right. And then let us write down our angles. Right. Remember that this is making an angle of 45 degrees. Right. So it's south 45. So south. So this angle here is 45 degrees. Right. If that's 45 degrees, we know that this angle here is 180. Right. So 180 minus the 45 gives us that angle. So what is this angle equal to? As in, what is this angle equal to?
It's 135.
135, right? Now, if that's 135, right, that's 135, this angle alternates with this one, right? This angle alternates with this one. So if this is 135, it means this here is 135 as well, right?
Yes.
Right. So this angle here is 135 degrees. So this angle is 135 degrees, right? So now you label your parallelogram. Let's call it A, B, C, call this D, right? And then your parallelogram is complete. Now you can look at questions, right? The angle we have is such that, what is this? Now here, this is, what is this? This is resulting velocity, yes, right? So with this one, the angle that we have is not an included angle, right? So meaning here we won't be able to use the cosine rule, because if you look at this angle, right, it is between this vector. We know this vector, it's 72 kilometers per hour, but we do not know this one. So this is between two sides, right, of which we do not necessarily know the magnitude of one. Hence, it is not an included angle. Right. Now let's look at the question. 121 calculates the direction in which the aircraft must fly to get to the airport. All right. So they want us to calculate the direction in which the aircraft must fly, right, in order to get to the airport, right? Now that direction will either be referenced from the y-axis, that's that direction, or the x-axis, which is that direction, right? We are going to stick with what is convenient based on our parallelogram, right? So based on our parallelogram, that angle will be this one. Is that clear to everyone?
Yes, sir.
Yes, sir.
Right. So remember,
Yes,
we
sir.
established that the plane needs to take this direction, right, in order to end up directly north after flying 275 kilometers, right? So when they ask you to calculate the direction in which the aircraft must fly to get to the airport, right? Remember our direction, or yes, our direction is either reference from the x or y axis, right? Based on our parallelogram, right? The angle we are going to calculate is this one, which is reference from the y axis, right? Right. Now let's calculate that angle, right? In calculating that angle, as we've established, the angle that we do have is not an included angle, right? So meaning we are going to use the sine rule, right? Using the sine rule, we are looking for A. So we are going to say in triangle ABC, right? In triangle ABC, we are looking for this angle A, right? What are we looking for? We are looking for this angle A, right? So if you're looking for that angle, right, that's the angle. So this side is A, this will be B, and that is C, right? So we're looking for this angle, right? The side opposite the angle we do have, and we have this angle. The side opposite this angle we also do have, right? So we are able to use the sine rule, right? So we then say sine A divided by side A is equal to the angle we have, which is angle C. So sine C divided by side C. Right, we are looking for A here. So it would remain with sine A is equal to, so you multiply by A both sides. This will be A sine angle C divided by side C. Right, so essentially looking for the angle A, we need to calculate the arc sine of A sine C divided by C. Right. So substituting, this is arc sine of A. A is equal to 72. Right. Remember, in a parallelogram, opposite sides are the same. So this side being opposite this one means this side is equal to 72 kilometers per hour. So this is 72 sine C. Angle C is 135. Right, divided by side C, which is the original vector, VO. So the 280 divided by 280. And what do we get as our angle here? What is angle A equal to?
It's 10,475.
Right, 10,475 degrees. This means the direction to be taken. Right, so direction to be taken. Right, the angle that we calculated is reference from the y-axis. Right, so the y-axis.
So sir, it's
yes.
if you round it off to 3 decimals, is 476, sir. So okay. Not 75.
All right, so 476. Right. Then you'd say the direction to be taken. Right, you look at where this angle is referenced from. It's referenced from the y-axis. The y-axis are going north, right, and the plane is headed somewhat west. So this is actually north 10,476 degrees west. Right, this part here is very important. But don't just write down the angle and not write down the direction. Are we clear?
Yes, sir.
Any questions?
Sir, I have a question. Would it also be possible to calculate the direction using the method of components?
Yes. Uh, yes. 100% yes. I'm just thinking.
Okay.
Because it's gonna take a while. That's why I actually like the parallelogram method,
The
because
parallelogram method, it seems more convenient.
it's always convenient, right? So especially for this case, we have to calculate the angle, right? Um, so I'll do it and I'll send it to the group because it's gonna take a while,
Yo. Okay, sir. Thank you.
right? But you'd essentially apply the very same principles, right? You get your vectors are oblique, you resolve them into its components, right? Then you apply conditions of equilibrium, right?
Yes, sir.
Right. Any more questions?
Sorry, sir.
Sorry.
My question is regarding how did we, maybe it's my ignorance, how did we end up in the second quadrant for VO, not the north?
Right. Now, remember that VO, right? VO, the 280, right? This is with no wind interference, right? So knowing that the plane must fly to an airport that is directly north of its position, right? If there was no wind here, you'd simply fly from this point, right? Fly from this point with 280 kilometers or at 280 kilometers per hour and end up directly north, right? That is with no wind vector. But now there is a wind vector, right? The wind vector is blowing in a direction that is south 45 degrees east. Now, how does this, or how would this affect the plane if we simply took off from here and tried to fly directly north, right? The wind vector would push us into this quadrant, hence would end up somewhere here, which is not directly north. So to counter the effects of wind, right, we simply fly somewhat off course, while knowing that the wind is going to blow us back on course and end up going or end up directly north after flying 275 kilometers.
Maybe how do we know that the wind is gonna blow us back?
Because of the wind
Because
direction. Remember, the wind is going in this direction, right? The wind is going in that direction. So if this is the tip of the
yes,
plane, right? So if this is the tip of the plane, right, this wind vector would blow the plane in that direction, right? So this here is going in that direction. This is going in that direction, right? So if we're flying such that we are trying to fly directly north, right, this wind vector would blow us, right, would blow us. So this would end up from here, this will be blown to that direction.
sure, I get it.
Right? So to counter that effect, it means we need to fly in this direction. Right? And then the wind will still blow us in that direction. Hence, now we would end up directly north.
Okay, makes sense. Thanks.
Right. Any more questions? Right. Right. And that's how you would get the direction that the plane must take in order for us to end up north. Right. So now we are going to look at this is this is 1.21. So now we look at 1,2.2. 1.2.2. Right. Calculate the time the flight would take. Right. So now they want us to calculate the time that the flight would take. Right. Now, in order for us to be able to calculate the time, we first need to calculate the resultant. So we need to calculate this resulting velocity. Right. And then in doing so, we know what is this? We know V is equal to S over T. So from this, you'd simply solve for T. Right. So this would be the resulting velocity. This would be the displacement, which we've already been given. It's 275. So once you've calculated this we already have, we'll then solve for T. Are we clear?
Yep.
Loud and clear.
Right. Now, so let us first calculate the resultant. Right. Our resulting velocity. Right. In calculating our resulting velocity, we would need to have this angle here. Right. We need to have that angle. So in getting that angle, we know the sum of these angles sums to 180. We already have this one and we have this one. So we'll be able to get that. Right. So essentially we say to get the angle B, right, in triangle, this is triangle ABC still. So ABC, we are looking for the angle B. Angle B is equal to 180 minus 135 minus 10,476. And what do we get here? What is 180 minus 135 minus 10,476? What do we get?
34,524.
Right. So 34,524.
Yes, sir.
Degrees. All right. Now this angle, right? This angle is this one here. Right. So this angle is obviously an included angle. Right. It is between two vectors that we know the magnitude of. So we are able to use the cosine rule.
Sine rule. Cosine rule.
So in using the cosine rule, we're looking for B essentially. So you simply say B squared is equal to, what is this, A squared plus C squared minus 2AC cos B. Right? And we calculate, now we simply substitute. Right? What is A equal to? A is, side A is 72. So this is 72 squared plus C squared. Right? C is the 280. So this is 280 squared minus 2 into 72 into 280 into cos B, B being 34,524. Right? And let's see what we get for B squared. So if you add this up, you are going to get, what are we getting? Let's go, people.
50,364.
So 503
Still typing it in, sir.
80,
801.
Yeah.
801. Right. So now you simply apply the square root both sides for you to get B, and what you get is B.
224,421.
224,421
Yes, sir.
kilometers per hour. Right. So we have the resultant. What are we looking for? We're looking for the time. Right. So knowing that VR is equal to S divided by T, right, it therefore means to get T will be equal to S divided by VR. Right. S is equal to 275, right? Yes, there. It's 275. So the displacement is 275 divided by VR, which is 224,421. Right. Now this is in kilometers. This is in kilometers per hour, meaning that the time we are going to get here is in hours. So what's the time in hours?
1.225.
1.225 hours. That's it. Right. And then if they specify that they want you to calculate the time in minutes, then you'd obviously multiply this, right, by 60.
6.
And then if they wanted it in seconds, you multiply this by 3,000. Yes. If they don't specify, you can leave it in whichever unit, hours, seconds, doesn't matter.
Doesn't matter.
Are we clear?
Yes, sir.
Yep.
Right. Any questions? Any questions?
All good.
Not from my side.
All right. Okay. So if there's no questions, all right, we can move on to the next question. Right, next question is on, right, projectiles. This question is on projectile motion. Right. Now let us look at this question on projectile motion. A boy throws a cricket ball at an angle of 15 degrees to the horizontal with an initial velocity of 50 meters per second. The path of the ball is that of a projectile. Calculate the following. Right, so let us first draw our, essentially our free body diagram. Right. So the angle here, right, a boy throws a cricket ball at an angle of 15 degrees to the horizontal. So this angle is 15 degrees, right, with an initial velocity of 50 meters, right? So the initial velocity is 50 meters per second, right? So obviously this projectile is at an angle, right? So because it is at an angle, we need to resolve it into its components, right? We need to resolve this into its components. Right, resolving it into its components, we are going to have a horizontal component, which we'll call UH, or you can just simply call it UX. That's fine as well. All right, and then this one, will be the vertical component. So this one you can call UY, right? So this is the initial velocity in the x direction, or the component of the initial velocity in the x direction, and this here is the component of the initial velocity in the y direction. All right. As we know that if the cricket ball, or as the cricket ball approaches the apex, right, it loses velocity in the y direction. Why? Because of gravitational acceleration. Right. In the x direction, the velocity of the, or the projectile of the ball doesn't. Yes, the velocity of the ball doesn't necessarily change. Why? Because there is no acceleration, no external force, right, to change the velocity in the x direction. Hence, even at this point, you'll still have UH, right, and this will still be UH, right, UH. Now, the velocity of the ball in the y direction at the apex, right, so Vy will be equal to 0 meters per second. Right, that is essentially the turning point of the projectile, the apex. That this is as far as the cricket ball goes before returning back to the ground. Right, and this here is the maximum height. This is H max. So this is the maximum height that the ball will reach, essentially. Right. So this is what we're looking at. Right. This is what we're looking at. You have UH, which is equal to, it is the horizontal component. The angle, the projectile angle is measured from the, or is referenced from the x-axis. Therefore, this will be in terms of cos. So this is 50, cos 15 degrees. And then we have the y component, which is uy, right, which will be 50 sine 15 degrees, right? And that is pretty much it. That is all we have, right? That is all we have. Right, now we look at questions. All right, we look at questions, calculate the time to reach the maximum height. So the one has to calculate the time it took for the ball to move from this point to the maximum height. Right? So essentially that's A, take this as B. So that's B, take this as C. So they want us to calculate the time it took for the ball to move from A to B. All right. Now, as we know, on the, as far as the y-axis, or as far as the vertical plane, right, we have quite a few equations of motion that we can use, right, depending on which one is convenient for us to use. Right. Now, for this case, based on what you've been given, you have on the vertical plane, you have the initial velocity, you essentially have the final velocity, right? You have G, and you're looking for T. So the most convenient, this is 1.3.1, 1.3.1. The most convenient equation of motion to use here is this one. So final velocity in the y direction is equal to the initial velocity in the y direction plus gt, right? Yeah, times gt. So the t we're looking for is between a and b, right? We have vy, we have uy, we have g, right? Now, as far as the g, when the object is still approaching the apex, we take g as being negative because it is essentially opposing motion, right? So vy we know is equal to 0, uy is equal to 50 sine 15 plus, and then g we take is negative 9,8 times TAB. Right, now we can take this term, transpose it to that side. So when you transpose that term, it then becomes positive TAB is equal to 50 sine 15. Right, and then solving for the time, you then divide both sides by 9,8. Right, that cancels. And what do we get as the time? What is 50 sine 15 divided by 9,8?
It's
1,321.
1,321.
1,321.
Correct.
Right, 321 seconds. Right, projectile motion, we shouldn't be even doing. It's pretty straightforward because it's simply using equations of motion. Right. Any questions here? No questions.
No,
Nice.
sir.
So 1.3.2. 1.3.2, what are we looking for? The maximum height reached by the ball. Right. Again, you simply look at what you have, what you're looking for, and decide on which equation of motion is convenient to use. Right. Again, we have V, we have the initial, we have the final velocity, we have G, we're looking for the height. Right. The most convenient one to use would be Vy squared is equal to Uy squared plus 2GH max. Right. If you look at this one, we have this, and we have that. So we can solve for H max. Right. So we know this is equal to 0 squared. U is 50 sine 15, all of this squared, plus 2 into negative 9,8, right, times H max. Right. Now, what is 2 times 9,8?
19,6.
19,6.
2 times 9,8.
Yes.
Yes, it's 19,6.
So 19,6.
It's 19,6.
The 19,6 is going to be negative this side. So when you transpose it, it will then become positive. So this side you'll have 19,6 H max is equal to the 50 sine 15 all squared. So because you're looking for H, we then divide both sides by the 19,6. 19,6. So H max is equal to, now what do you get here? What is 50 sine 15 all squared divided by 19,6? Right, so this is 50 sine 15 all squared divided by 19,6. What do you get?
8,544.
So 8,544 meters. Right, are we in agreement?
Yes.
Yes, sir.
Right, now let's look at the last question. Question 1, calculate the range. Right, so this here is the range or horizontal displacement. Right, so this is the range or horizontal displacement, S sub H. Right, this is what we're looking for, the range. How do we calculate the range? 1.3.3. Right, as far as the range, it is in the x direction. And in the x direction, as far as equations of motion, we only have one formula. Or we only have one equation of motion. Right? And that is one of the displacements. Right, so SH, or you can say the range, is equal to UH times T. Now the T is the time it took the cricket ball to move from A to C. Right, so this is essentially AC. Right, now what is AC? Right, the time it takes the cricket ball to move from A to B is the same time it takes the cricket ball to move from B to C. Right, so meaning that TAC is 2 times TAB. Are we clear?
Yes, sir.
Right, the time it takes the ball to move from A to C is double the time it takes the ball to move from A to B. Are we clear?
Yes, sir.
Right, So meaning this is essentially equal to UH times 2 times TAC, right? And we've already calculated not TAC, TAB, right? And we've already calculated TAB, right? So UH is 50 cos 15 times 2 times TAB, which we got as 1,321, right? And what do we get here?
127,598.
Right, 127,598. Right, so this will be 599 meters, right? Because there is an 8 after the 8. So running off to 3 decimal places, you'd get 599.
Yep.
Are we clear?
Yes, sir.
Right. Any questions? Right. So if there are no more questions, I'll be sending this to the group. This session has been too long. So we're going to do the second part. I just have to think now.
Tomorrow?
Tomorrow, I have to see another group. Tomorrow. Okay, let's meet tomorrow. It's fine. Tomorrow might be a problem. Might be a problem. Okay, tomorrow is definitely going to be a problem because I have to see another group tomorrow. 2 groups, in fact. So let us say Friday. So Friday we'll look at the question on beams, the homework, and then we will look at what is this? What did I send you? Stress and strain.
Yes, stress and strain.
So we want to look at statics, then we're going to look at stress and strain, how we approach problems based on stress and strain. Right.
What is it?
Yes.
Can you send us the questionnaire of the 4th week as well, please? I think you only sent us the answers, though.
I'll send the questions as well.
Okay. Thank you.
Right. There will be some homework I send you today on kinematics. So that homework is going to help you towards preparation for next week, test 2.
Yes, sir.
Are there any more questions?
Sir, sorry. I just want to find out on the next week, are we writing on Tuesday, right? And
Yep.
what is going to be covered there on that test?
So on the test, it will be the 2 modules which we've covered so far.